right, everyone. Thank you all for showing up. I know it's the afternoon, so lunch is probably kicking in. But yeah, this is a really interesting topic, so I hope it wakes you right back up. So today's speaker, we have Craig Johnson, who is a technical solutions architect at Forward Networks with over 3 years of experience working with AWS. And today, he'll be talking about cloud networking and how to use native tooling to troubleshoot on AWS. So without further ado, let's introduce Craig.
Thank you, much appreciated. First to start off, I'm curious, who here would consider themselves a networking person, network engineer, anywhere in that area? Okay, great. So even if you're not, I promise you'll learn something here, and I promise you'll be able to use this to help inside your environment. So a little bit about me. So I've only been using AWS, or probably about 3 years. Most of my career is on-prem networking. So I worked at Cisco for many, many years. You can see I've got several certifications there. But the past few years, I have been completely cloud native. And what I've noticed is the way we troubleshoot on-prem is not applicable to how we troubleshoot inside the cloud. And the problem is I don't have the same levels of tools. But there are those tools available, and actually Adam mentioned VPC Reachability Analyzer this morning. I'm going to talk a little bit about that today and show you how you can use the tools that we have in AWS at no extra cost today to do the same level of troubleshooting that we could do on-prem whenever there is a network outage or something isn't connecting to something. So are the tools I have today good enough? So if I was working on a Cisco router, what would I do? I would SSH to that router. I would do a couple of show commands, look at the routing table, look at the forwarding table, look at the BGP database. I can't really do that on AWS. I can't SSH into a transit gateway to see what's going on there. I can look at a particular routing table in there, but there's a lot of different places to check. I have to check my subnet routing table. I have to check my transit gateway. I have to check network ACLs and security groups. That's only counting for one region. If I'm looking to go across region, now I've got to jump to that. And then if I have multiple accounts, that just gets even more and more complicated. So the way I've seen people try to troubleshoot things on the cloud today is simply staring at output and say, does this routing table look right? Okay, how about this one? How about this one? Alternatively, what people do is they use what are called VPC flow logs, so to be able to look at the traffic. That's not how we troubleshoot on-prem. That's the equivalent of putting a sniffer on there and seeing if the traffic is there. That only helps you if the traffic is going on right now. So what we're going to discuss is how we build the infrastructure to do cloud-native troubleshooting. We can include our on-prem networking as well. We can go between regions. We can go within a VPC. And I want you to walk away from this knowing how this can be used to help you. So like I said, there's no router to log into more. I don't really have the same routing protocols. Like if I was doing anything on-prem, I could look at my BGP or OSPF database. There's a little bit of BGP inside AWS, but it's almost purely point-to-point. It's between my on-prem router via a direct connector, a VPN, or my transit gateway peer to something else. It's not really a full BGP database that I can actually do path tracing. And I can't do the same sort of pings and trace routes. Those things really don't work very well, either because of security or just because it's disconnected so ICMP doesn't get traced. So I can't use the, can I ping something doesn't work. Just because something isn't pingable doesn't mean it's not being able to connect. So understanding the traffic flow in this environment is more critical than ever. And like I mentioned, if you use something like VPC flow logs, those only really work if the traffic's actually going on. If something's completely broken, obviously there is no traffic flow. You don't know what's going on. And if I'm going across multiple places, I have to check those flow logs within every VPC, every subnet that I have enabled. So the good thing is there are a lot of tools built into AWS that don't cost you anything that I don't see a whole lot of people use to be able to create a visualization of your network and use that to troubleshoot. So a couple of the ones we'll talk about today. On this list, you've got Cloud WAN. That's kind of more of an advanced transit gateway. Infrastructure performance is pretty cool if you're actually trying to see what the latency is between availability zones and regions. Today, we're going to talk about Transit Gateway, Network Manager, and Reachability Analyzer. There is also Network Access Analyzer on the security front if you want to start looking at, are my instances open up to the internet, things like that. So as I mentioned, what we do is we use the CLI to troubleshoot. because that's the best way to figure this out. Now, when you can still use the GUI, but the examples I'm going to show today are purely going to be using the CLI. Now, when you're a network engineer, you're always the glue of the entire network. When something is down, everyone says it's always the network, because the network is the least understood out of everything out there. And when it breaks, it affects everything. So keep that in mind when we use these tools to troubleshoot versus the way you do it today. Like I mentioned, we're going to try to use simply CLI tools. That way, I can start to integrate these into workflows a little better. It's still handy to use the GUI, and I'll have some examples with it. But I want you to get in the habit of actually using CLI or API to grab this data. Like I said, no pings, no trace routes, no inbound tools. I'm not going to be actually looking at live traffic. I'm going to be analyzing the flows and paths inside my environment. So the first thing we need to do is we need to create our map of the network. So this is Transit Gateway Network Manager. So I'll show you a couple of commands here. I'm going to say AWS create a network manager, create global network. Then I'm going to create my sites. What this will let me do is this will let me connect any on-prem site. So I have my global network, and then if I have actual either VPN connections or data centers that connect up to AWS, I'm going to create that here. Reference my global network that I just created, and then I can give it a latitude and longitude. Why am I doing this? Well, now this will give me a nice visualization. So I can show people, if someone asks you, hey, what does our AWS environment look like from a network perspective? I'm going to have a map to be able to show it to. And of course, I have something I can export as well. So I'm going to create a device at those sites. So the device is essentially the on-prem router you have. So even if you're not managing it, you still need to be able to say, hey, if I'm going from a data center here in the Bay to somewhere in New York, I want to be able to reference those data centers as routing points. The site that I just created, give it that latitude and longitude. Create any links between there. So we're automatically going to pull in things like VPNs and Direct Connect, but if there are other links in connectivity, you can use this here as well. The great part about this is this is going to be completely dynamic. So once I've created this, if I change my transit gateway peering or add a VPN, it's going to update the map automatically. Give it that site, and then I can even put bandwidth and upload speeds and things like that if I really want to start looking at, what is the latency between here, or what kind of bandwidth I'm looking at. So you can do this across accounts too, and that's what's really cool here. So it's one thing to say, okay, I've got one AWS account, one region. This will cover all of your regions. And you can, if you have organizations and you have multiple accounts and they have their own transit gateways and VPCs, you can pull those things in here as well. So you'll get a full end-to-end view of the entire environment. Now, we're going to associate. The next part here, this is the cool dynamic part. We're going to take our transit gateways. So any transit gateways that I have in any one of my regions, I'm going to take them and I'm going to register them. Because typically that is my brokers, where I have connections to VPNs, it's where I have connections to anything on-prem with a direct connect, it's where I attach any of my VPCs in the environment. Same thing, reference the global network, give it the ARNs. Now I'll show you in the GUI, this is a little easier to set up there, but this will let me do that level of association to bring those things in there. And any customer gateways for that on-prem connectivity. So what does that do for me? Well, now that I've created that, this creates a topology graph for me. So now I know exactly what my network looks like. These are my transit gateways right there. These are VPNs that are connected to them. These are all my VPCs that are attached to them. So now I have a view of, here's US East 1, US East 2, US West 2. No matter how big it is, you can just point this out and say, here is what my environment looks like and how everything is connected. So that's the hardest part about being an on-prem network engineer, is the documentation is always out of date. You have Visios or Draw.ios, and it's only as good as what the latest one is. This being dynamic, you'll always have an up-to-date view of your environment, because we'll automatically pull anything new. If you add no VPN connections, add more direct connects, you'll be able to see everything there. You even get kind of a more broad view if you want to see the topology here. So you can see all the VPN endpoints here. You can see how they connect to any data center, all the way up and down the line. So now that I've created my environment, let's say I'm having a problem. Let's say I'm having an issue connecting from an instance in US West 2 to something in US East 1. How would I normally troubleshoot that? Well, what we would normally do is I'd log, say it's not working. I don't know what it could be. It could be a security group rule. It could be a routing problem. It could be something's actually down. I'd have to log in to both those regions, check the routing table of the VPC, check any security groups or network ACLs, check every part of those connections. I'm going to use Route Analyzer to do this job for me, though. So I'm going to do what's called starting a route analysis. This will start to analyze the path from any source to any destination. All you have to do is give it where I'm attached to and the source and destination IP addresses. Start the route analysis for that global network, specify what my transit gateway is and the IP address. So that's my source, that's my destination. You can also include the return path. Because keep in mind, just because I can go from US West 2 to US East, there's a whole set of reverse routing rules to get back there. So you want to be able to say not just how do I get there, can the traffic get back and does it get back symmetrically? I can also use middle boxes. This part is really cool. So of course, if you have something like a third-party firewall vendor, an SD-WAN component, something like that, obviously AWS doesn't have access to it, but we will know that the traffic gets delivered to that thing. So assuming that that middle box is doing its job, we can say, use the middle box and say, hey, I'm going through a Palo Alto firewall. I don't know that it's configured right, but I'm going to assume that the traffic's going to come in and come out of that box. So you can analyze the path end to end. Why is this important? I need to be able to say the network is configured correctly, and I need to be able to prove it. There's a thing we say in networking. It's called mean time to innocence. It is being able to prove that the network is not the problem, and this data will arm you with that. So now that I start the route analysis, specify the same thing there, start the analysis there. The cool thing about this is a point in time. So I said, just because the network is working now, if I put these in my pipelines, use these as part of my acceptance testing, I can say the network has been up this time and was up yesterday, and it was up the day before. So now I have a way to prove that, hey, we had a transaction failure last Saturday. Was the network configured correctly? Yeah, we run this every time we do a check every day. Yep. Sorry?
That like a best practice then in terms of pipelines?
Absolutely. So what you want to do is you want to put these sort of things inside any acceptance testing, inside any change control, to be able to run these every time. Because you need to be able to have the ammo to say it's always up every time. So here's my results. So what I get here is the route analysis will tell me, does it work? And status right there, succeeded. So now I have a success, and it tells me every place that it passes through. Now I'll give you the GUI view because it's a little prettier. It's going to tell me, okay, my source and my destination. You didn't know anything about the path of this network. You knew kind of where it was, but you didn't know anything in between. Just by specifying the source and destination, it's going to tell me every place it goes through in my environment. So as I start off at a transit gateway attachment, that transit gateway attachment has a routing table attached to it. That goes to a transit gateway. Here's my transit gateway peering from US West 2 to US East 1, all the way end to end. And because I actually put in the return path, now it's telling me how I got back there. So now I've proven that inter-region, my connectivity is working correctly. That's not quite enough, though. So this tells me that my broad level connectivity works right. What if I'm having problems just within a region? Let's say I have two instances that can't communicate to each other. And I don't just want to check the path. I need to check more complicated things, like are my security groups configured correctly? Are my network ACLs set up right? That's where we can start looking at another tool, Adam mentioned it this morning, VPC Reachability Analyzer. This will start to tell me those levels of very, very detailed information to tell me if everything is configured right. So let's set up a path to do that. So this one's a little different. It's under EC2, so create network insights path. I put on a source, I put in a destination, I can select the protocol. So if I'm actually trying to simulate a transaction, so I can select instances, internet gateways, NAT gateways, transit gateways. I can check all sorts of things here now that I'm inside a region. I start the analysis. So notice these are broken up into two parts. I create the insight path. So this is if you do this proactively, this is great for troubleshooting, but if you do this proactively, like this is a standard application flow, this is something that I care about all the time, it always should be up. Now that I've created this, I can run the analysis whenever I want to. This is part of the pipeline I mentioned. So I can start to say, let's run this analysis every day at midnight to make sure that this is healthy all the time. Or if I'm doing any sort of change inside the environment, I call it with a Lambda and put it in my CloudFormation template. So now I'm going to describe what that path looks like after I've done this. So now that the thing about this is now think about all the predefined paths I have. I can create a whole roster of all of the paths that are important inside my environment. So here is what I've got here. So when I did the analysis, it tells me my source, my destination, network path found, false. So this didn't work. So it's going to tell me, OK, well, explanations. Why didn't it work? Direction ingress, ENI, SG rules mismatch. So I have a security group that is missing the right connectivity from my source to my destination. Tells me the exact security group, that's the problem. Now, I can also look at this via the GUI. A little small to see here, but it's going to tell you more detail than you had before. I've got my source, I've got the routing table, but I also have network ACLs, I have security groups. It's also going to tell me if I cross an availability zone. That's really important for latency. Like if you didn't know, and also for cost control as well. If you're crossing from US West 1A to 1B, that's 100 miles apart. If your application's latency sensitive, that could be a thing. And also, you're going to pay cross AZ fees to do that. So you get that level of analysis too. And the one in red, it's telling you exactly what I showed you on the screen before. I have a security group rules mismatch. Then, when I click on it and open up, I see my security group rules. I was looking for 3389. I'm only allowing SSH in, so I know exactly what I need to do to fix this problem. Without this tool, without this ability to run and check this, these are all the different places I need to look every time I'm having a problem. That assumes I know what the network looks like. With this, I don't really need to know what the network looks like all the time. I can go into any customer's environment, start using this. The only thing that your app owner or your NOC is going to have, source IP, destination IP, and optionally a port of protocol. So now, when I fix that, keep in mind this was a point in time. So it's broken. OK, I see what it is. I'm going to fix it. I don't just want to fix it and say, try it now. I want to be able to verify that it's working before I tell my customer or my client to try it again. I run the analysis again after fixing that. And now it tells me succeeded. So I don't get the explanation, but it tells me it's working correctly because I've run this analysis again. And in the GUI, you'll see every time that you have an analysis, so you can go back as far as you want to see what it is. These things, it's a very nominal cost to use, something like 10 cents a query to do this. So very, very manageable cost to run these. But it's a tool that you have to be able to prove that things are up and running and working. So it's not just for troubleshooting. So troubleshooting is a really cool use case, and it's probably the first one people start to use this for, because when something is not working, being able to check all of these things very, very quickly is very cool. But you can make this a bit more proactive. Like I mentioned a little bit before, use this within a Lambda to pre and post change, do checks on there to make sure that if it failed after I do the change, have it roll back that change because you know the network is broken before any of your users do. Integrate this into a pipeline, so whenever you are doing these checks, you have a full acceptance, you have a full closed-loop verification inside your environment. So what else? Defining these critical application flows. Now I have a full matrix to prove out. Here's all of my app flows that I care about and are important. And so anytime someone asks me about the health of the network, I don't have to guess and say, yeah, it's fine. I have documentation, and I have proof to show it to them. So what else can we kind of do with this a little bit? So these tools are available to help you inside your environment. Works on-prem and other middle boxes. It's really important. It's not hard to do. I showed you kind of the CLI way, which is probably a little more involved. But you do this in the GUI, creating the network map, which does not cost you anything. It's built right into Network Manager. you can use this to create your environment, show exactly how it works, and start doing levels of troubleshooting and verification inside your environment. Everyone relies on flow logs, and I understand why they do, because it's actually telling you what the traffic looks like, but they're a crutch, and they won't help you if you are troubleshooting in isolation. Oftentimes on the network, we don't really get the luxury of seeing what the transactions are, what the actual traffic is. We just see the, we just see the infrastructure. And like I said, I don't even get to simulate with pings or trace routes anymore. So when you start building these proactive checks, you can start to enable a little more self-service, because I can provide an API, and they say, hey, I've got one customer that is using Reachability Analyzer. It executes an API via Slackbot. So they simply open up the Slackbot, and they say source, destination, the only information they have, source IP, destination IP, and it will return back from Reachability Analyzer, does this work or does this not work? So now you have more of a pro, so they're not bugging you to fix these problems. Now, I will say the hardest part about this is building those checks, because you may not know what all the application flows of your network. And that is where something like VPC flow logs can come in. You can start to collect a data, a baseline, and say, okay, here's all my top talkers in my environment. Build the application checks from that. And that's a great use for something like SageMaker or Bedrock, that you can just feed those into it, and it will generate the Suricata rules or whatever you need to actually create those things. So thank you. I appreciate the time. I'll go ahead and open up for any questions.
Before we begin with questions, can we get a round of applause for our amazing speaker today?
Yes.
All right, I'm going to ask you, when you do ask a question, raise your hand so I can come to you. That's just so the camera can pick it up. Otherwise, it can't hear the question at all. This session is recorded and will be available later. So yeah, feel free to go ahead with the questions.
Hi,
Hello.
it was a great session.
Thank you.
And because I'm a little bit familiar with the networking term from my bachelor's, but this was great to know. And actually, I want to know more about latency, and you mentioned middle boxes.
Yep.
So how it is there in the pipeline, and like, is that like you said about the analyzer? So is there any cost to it, and how it affects? Like, suppose there's a professional company, they're a startup, and they want to use this. So
Yeah, the cost is
nothing.
very it's
Okay.
literally 10 cents a query to run the
Okay.
Reachability Analyzer, so it's very minor. Even if you run it every day on 10 flows, that's $1. So
Yeah.
yeah, it's extremely low cost.
Yeah, because it's like if we use another EC2, like EC2 or something like that, there are free tiers, but then we have someone paid. Like if
Yeah.
there is a scalable and their high scale application is there, then it needs more compute power and memory. Everything goes along with
Yeah,
that.
this is not a scale-up cost. It's literally a per query. Now, what Adam said this morning, this is integrated into Amazon Q as well, so you can ask it just natural language. Can I get from source and it will create a VPC Reachability Analyzer query, so you can go back and see it. So that's a cool use. That's brand new. I didn't even know that was there.
Yeah, that's great. Yeah, we just attended the Amazon Q.
Oh, nice,
person.
nice.
Yeah, it was nice. Yeah. So yeah, thank you.
Thank you.
So you mentioned multi-account setup in the beginning, right? So just curious, so when you have a complex setup like this, would you rather set up all the networking elements in one account, or would that be distributed?
Typically, if you look at the landing zone kind of architecture, the network components, like the big ones, like transit gateways and stuff, tend to be in their own account. And any sort of shared services, like firewalls, things like that, they will be in a services account. And all of the clients will be VPCs that are attached to that transit gateway that are in the services account. So it's why important, if you want to get that full end-to-end, if you're using organizations, you just turn that on and you can pull in all the accounts. But yeah, typically the architecture you see is you'll have a network team that keeps the common network services like transit gateways, direct connects and connections there inside a particular dedicated account.
And do you have experience running the reachability analyzer across multiple accounts? Does it work?
Yeah, as long as they're in the same organization. It does not work across organizations yet, and it doesn't work in GovCloud, so if you do a little bit there, but in every other instance it works great. Yeah, you just need to have appropriate organizations access.
Thanks.
I'd be impressed if we had any GovCloud
Yeah.
customers in here, but
Yeah, I work a bit on that side, so yeah.
all right.
I gave the same talk at Summit DC, and they're all in GovCloud over there, so yeah. That part was a little...
Yeah, less so outside of Arlington, right? Any more questions? I have a question myself, actually. So you talked a little bit earlier about people who are kind of new to these services. You mentioned something about doing checks with Bedrock and SageMaker. Can you kind of go a little bit deeper into that, just for the people who aren't as familiar, and kind of explain, like, that process again?
Yeah, so if you turn on VPC flow logs on a VPC, it will flood with a wealth of data. Now that does have a cost because it's depending on how much data is flowing through there, but you will get these reams and reams of all the different flows on your account. Now you could go through and sort and figure out which ones have the most bandwidth, have the most there, but it's way easier to use something like SageMaker to just feed those logs in there and ask what are the top talkers? Give me the top 10 applications across my whole environment. Because every VPC flow log is within a VPC. So if you have even more than just a few VPCs, trying to do this yourself, the data becomes very, very overwhelming. And that's where it becomes really easy to just feed it into something. And then you can start to update that on the fly, because you can say, okay, I run the flow logs whenever I have big transaction times, and then I say, okay, then I can automatically update whatever new applications come online in my environment. So that's what I've used SageMaker to build something like that for a customer.
Great, thank you so much. Any more questions around the room? And of course, Craig will be available after this event,
course,
right?
yeah.
He'll be hanging around. You can spot him a mile away with that shirt.
That's
so.
right, yeah. It's sparkly.